Have you ever just stopped and thought about what it takes to run a service for a billion people? I mean, every single day, Google is dealing with this absolute tsunami of data from search, from YouTube, from maps. It's a scale that's almost impossible to wrap your head around. So how on earth do they do it? Well, the answer is inside a powerful, custom-built engine. And we're going to dive in and see exactly how it works.
Right, so this isn't some abstract thought experiment. It's the real, honest-to-goodness engineering challenge that defines a company like Google. You have to design systems that can scale, that are super reliable, and are just lightning fast for over a billion people. As our source material points out, this is the Mount Everest of software development. So where do you even begin with a problem that massive?
Well, lucky for us, the answers are kind of hiding in plain sight. For this explainer, we're cracking open the book System Design at Google. Think of this as our treasure map. It's going to guide us through the incredible tools and systems Google had to invent to solve problems that, frankly, no one had ever even seen before.
So here's the thing about operating at what they call planet scale. You can't just go to the store and buy software off the shelf. It doesn't exist. Any normal system would just buckle and break under the sheer amount of data Google handles. They figured out really early on that to solve their one-of-a-kind problems, they had to become master toolmakers first, building their own tech from the ground up. And man, what a toolkit they built. We're talking about legendary stuff here, like Bigtable, the database that basically kicked off the whole NoSQL movement, or Dapper, which lets them trace what's happening across their gazillion servers. But out of all these amazing tools, there's one that really stands out for its ability to make sense of all that data. So today, we're going to zoom in on one of the heavy hitters in their arsenal, BigQuery.
All right, let's shine a spotlight on Google Cloud BigQuery. The best way to think about it is as Google's secret weapon for data analysis. It's a tool so unbelievably powerful, it can sift through literal mountains of information in what feels like the blink of an eye.
Okay, I know, that is a whole lot of tech speak. Let's break it down. The two words you really need to care about are fully managed and serverless. For a developer, what this actually means is you never have to think about servers. No maintenance, no configuration, nothing. You just upload your data and you start asking it questions. It scales up or down automatically. All those engineering headaches, poof, they're just gone. And that, right there, is the magic trick of BigQuery. It gives you all of Google's insane computational power, but you don't have to deal with any of the crazy complexity underneath. It doesn't matter if you're looking at a few gigabytes of data or a few petabytes of data, the experience feels exactly the same. The bottom line is you get to focus on what actually matters, your data, not on all the plumbing.
So how does this magic even work? Seriously, what is going on behind the curtain that makes BigQuery so incredibly fast and powerful, but also so simple to use? Come on, let's pop the hood and take a look at the architecture. Whoa, okay, I know what you're thinking. That diagram looks intense. But stick with me here, because the core idea behind all that complexity is actually brilliantly simple. If you remember one thing from this section, make it this. BigQuery's whole architecture is built on completely separating data storage from data computation. That single decision is the key that unlocks everything else.
Now, to make sense of that crazy diagram, let's use an analogy. Imagine a giant futuristic warehouse. All of your data, that's the stuff sitting on the shelves in a massive worldwide storage system called Colossus. When you ask a question, it's like placing an order. Borg, the central AI brain, immediately assigns thousands of little robot workers to go get your answer. These robots are part of a fleet called Dremel, and that's the computation engine. And how do they get the data from the shelf to the robot so fast? That's Jupiter, a mind-blowingly fast conveyor belt, a network that moves data at a petabit per second. It's this beautiful symphony of all these custom systems working together that gets you answers in just seconds.
And there's one other secret weapon we have to talk about, the way it actually stores the data. See, traditional databases store information in rows, just like a spreadsheet. So if you want to find the average of just one column, you still have to scan through every single piece of data in every single row. It's super inefficient. BigQuery's clever. It flips the whole thing on its side and stores data in columns. So if you only need data from 2 columns out of 100, BigQuery reads only those 2 columns. That innovation is a huge reason why it's so ridiculously fast.
Okay, I know we just got pretty deep into the technical weeds there, so let's pull back up for a second. What does all this fancy technology, this split between storage and compute, this columnar format, what does it actually let people do in the real world? Why should we care?
Well, it really all boils down to these huge benefits. You get blazing speed, which lets you do things like detect credit card fraud the instant it happens.
It's truly serverless and scales effortlessly, meaning a tiny team can build a recommendation engine that rivals Netflix without needing an army of engineers. It's cost-effective, so startups can afford to do complex analysis, not just giant corporations. And because the storage is separate, you can share massive datasets with other people without ever having to make a copy. It is, no exaggeration, a total game changer for data analytics.
And hey, when we say cost-effective, we really mean it. You only pay for what you use, the queries you run, and the data you store. And just look at that free tier. You can process a full terabyte of data and store 10 gigs every single month for free. That's insane. It makes this incredibly powerful technology available to pretty much everyone.
You know, our source material really sums it all up perfectly with this quote. It highlights that BigQuery is more than just a tool, it's a fundamental shift in how we even think about data. They call it a perfect blend of cloud computing and big data solutions. It takes all the hard, complicated parts of big data and marries them with the simplicity and power of the cloud. And as they say, understanding this is beneficial for everybody.
And that kind of leaves us with a final, really interesting thought. BigQuery is this powerful, almost invisible engine that enables so many of the apps we use every day without us even knowing it. And it just makes you wonder, right? As we keep creating more and more data, what other invisible engines like this are being built right now to make sense of it all? And what new possibilities are they about to unlock?